This screencast, we're going to look at Le Chatelier's principle and equilibrium. Le Chatelier's principle says that a system at equilibrium, if it's disturbed by some kind of change, a temperature, pressure, concentration, some kind of change on one of its components, by being at equilibrium, the system will try to reestablish the balance or the equilibrium in order to counteract the change that was just added. Just like if you were on a teeter-totter and you put another kid on, everybody would shift in order to return the fact that you could still seesaw back and forth. So here's our example. We have N2 plus 3H2 yields 2NH3, and these are all gases. So if you were to look at the concentration change, if you were going to alter the amount of N2, the equilibrium would shift in a way to return the problem back to the original state. So if you add a substance, you will shift in order to consume it. And if you remove a substance, you're going to shift to form more. Okay, so I have an example down here. If we added H2, so I'll use blue. If we add H2 to this reaction, you are going to shift in a way to consume it. So would we go to the left or to the right? If we're trying to consume it, we're going to go to the right. Okay. If we remove N2, we're going to shift in a way to form it. So which do you think that would shift? We're trying to form some more, so we would shift to the left. And then lastly, if we add NH3, we're going to shift in a way to use it up. So that also is to the left. Now, you will see problems on your test or in AP exam where they are going to say, tell the direction and justify. So you need to say more than just to the left or to the right. You need to say so that it consumes the particular substance and because it's on the reactant side, etc. You need to use more detail than just saying it shifts to the left or to the right. Okay, again, with Le Chatelier's principle, when you alter the volume or the pressure, now remember from our gas laws that typically as the volume goes up, the pressure goes down. So you need to think of it in terms that way. Again, we have the N2 plus H2 makes NH3. When you increase the pressure, you are going to try to reduce the total number of molecules. As you have more pressure on it, it wants to, have less molecules floating around. So you would go toward the side that would have less molecules. And if you reduce the volume, you would shift in a direction that reduces the number of molecules as well. So think about it as how much space you have remaining. So if we are increasing the pressure, which is also decreasing the volume, we're going to want to go to the side that has less molecules. And if you look at this equation on the reactant side, we have 4 molecules essentially, and on the product side we have 2. So we would want to shift in a way to have less molecules. So this one would go to the right because the right side or the product side would have less molecules. Now if we increase the volume and we have more space or decrease the pressure, we would shift the other direction toward the left. If you change the temperature or you have heat involved, you're going to treat heat as a product or a reactant based on the delta H value. So this is a little bit of a review. Remember, if delta H is negative, it was thought of as a product, and if delta H was positive, we had to treat it as a reactant. So that's just telling you which side of the equation that you would put the heat. When you change the heat, looking at it with Le Chatelier's principle, you're going to just shift to absorb it or reform it, just like we did with the changes in concentrations. So if we have heat, in this case that we have heat over here as a reactant, if we increase the temperature, we know that we're going to shift toward the right to reduce the amount of heat that's there. All right, last factor that they may show you on a problem and ask you how it affects Le Chatelier's principle and how it affects the equilibrium of the reaction is a catalyst. A catalyst is something that is there to speed up the reaction. It is trying to change the rate. It does not affect the overall equation. It just makes it go faster. So a catalyst in a problem and them asking you about the Le Chatelier's principle is kind of like a trick question. They really are just looking to see if you remember what role a catalyst has in the equation, and that it does not affect the equilibrium. So it would have no reaction, or no effect on the overall equilibrium.